Well, hey, everybody. It is 2 hours UTC on the 9th of August, 2018. And right now, at this very moment, we can all celebrate because Mercury is at inferior conjunction. So it is, in terms of right ascension, it's exactly lined up with the sun. Now it's a little bit south of the sun. It's about, I think they said like 4.8 degrees or so south of the sun. But right now, at 2 hours UTC, right now, it is exactly lined up in terms of right ascension. So, and it's moving west, right? It's moving west. So I sort of wanted to look at that first, but before I do, I just wanted to welcome everybody in. Take a look at the chat really quick. Tom, hey there. Cheers, Mercury. Yeah. And hey there, Bobby. Nice to see you in the panel again. What is going on down there?
Nothing much. It's a crazy day if you're police scanning.
Oh, was it?
It's a crazy day if you're police scanning around.
A lot of activity over there?
Yeah.
Do you listen to sort of the local stuff, or are you listening to more widespread?
It could be both.
Okay. Usually like local stuff, though?
So.
Yeah, okay, cool. All right, well, what I wanted to do first is say hi to Tom, say hi to Atawahinta in the chat. Nice to see you there. Glad you could come by again. Tom, I really like the paper that you posted. I want to take a look at that during this live stream, just sort of look at it because, yeah, it's quirky, but some serious work was done there too. So yeah, science can be a little off and a little weird and all of that. Otto thinks that, or thought at least, that all Southerners were pretty laid back, but you're talking about a lot of activity over there, huh, Bobby?
Yeah. Yeah.
Right. Cool. So what I wanted to do right off the bat is let's look at Mercury, right next to the sun, because I mean, come on, inferior conjunction. See, there are two. Here, let me do this first. So there are two planets that orbit the sun inside of the orbit of the Earth, right? There's Mercury and there's Venus. And if you know what, we can let's go over to CalSky, right? Let's go over to CalSky and take a look at a. Oh, I didn't mean to do that. See, let me start up my smartphone thing here. It says it's live. There I am. Okay, cool. Okay, so I'm going to share my share my screen. That's not hard to do. I'm going to hide that. And then let's go over here. I just tweeted that we are live now, as you can see. So let's go over to CalSky. I don't have to log in as an account or anything in order to see the solar system view. But I think, is it here? Overview, graphical almanac, graphical day-night calendar. I thought that there was. Oh, here it is. Okay, so, and this chart is a little hard to see because they also show. I think they're showing a lot of the asteroids and stuff. I'm not exactly sure. Anyway, here's the orbit of the Earth. Right, here's the orbit of the Earth, and here you can sort of see it's marked with an E right there. It says Earth, right? And so here's the orbit of Venus, and here's the orbit of Mercury. And of course, right in the crosshairs there is where the sun would be. Okay? So as you can see, if we're standing on Earth and looking towards the sun, right? So the sun and Mercury and Earth are right in alignment. And this is what's called inferior conjunction. So because it is in conjunction with the sun, right? It's sort of with the sun, but it's on our side of the sun. So that's called the inferior conjunction, right? So when this swings around, right? If it were over here, right, it would also be in conjunction with the sun, but that is called inferior. What's the opposite of inferior? Oh man, I just lost that term. It just flew out of my head. It's not exterior. That's the wrong term. Inferior. Inferior and man, why can't I? Superior, of course. Okay, so superior conjunction would be over here, right? So as you can see, just the inner planets are going to both have an inferior conjunction and a superior conjunction, right? Mars is going to have a conjunction, right? But it's always going to be on the opposite side of the sun, always, always. It's sort of hard to see that from here, but it's true. It's true. All right, so let's take a look at this Mercury right now, and we'll go right to the real-time GIF movies. So we're going to look at this wide field coronagraph image of the sun, and we're just going to sort of let this load. It takes a little while to load. Now, for a while, I was looking at this, and I'm sort of like, I don't see Mercury. I'm expecting. I have certain expectations in terms of what I think I'm going to see, and those expectations were not being met. Right? It's like I'm sort of expecting to see something relatively bright, something moving that isn't a background star, so it's going to be slightly moving differently. By the way, I don't know if you caught this earlier, but this little cluster of stars right there, that is that's the Beehive cluster, M44, right in the center of Cancer. So you can sort of see, you can't see those 4 stars of Cancer anymore, but when this wraps around, I think you get a little bit of a glimpse of it before it starts moving out. So as you can see, relative to the background stars, the sun is moving to the left. It's moving east. And that is because the Earth is revolving around the sun going to the right. And so all the background stars, is that right? Yeah, all the background stars also appear to be going to the right. All right, so let's see here. Almost done with this loop. almost done. And then, okay, so here's the loop. And as I said, I was expecting something relatively bright, but then I started to think about it. And, you know, when Mercury is in this configuration, we're mostly seeing the dark side of it, right? The sun side is being lit, and we're looking at the dark side of Mercury. So it's actually going to appear pretty darn faint. So it's probably pretty hard for you to see, but I'll let this loop one more time, and then I'll show you. I'll show you where, if you can't see it already. Do you see it, Bobby?
I saw like a little black blob while it was loading and stuff. I was wondering that was it.
Yeah, no, it actually takes a few days for Mercury to move through this field of view. So it's almost moving the same speed as the stars. But okay, so here I'm going to point it out. Here it is right there. So it's moving through that dark thing, and then it's coming. Do you see how it's moving a little faster than the background stars? That's it right there. Okay, it just started the loop again. So now if you watch it, you can sort of see that it's a little faint little dude, but he's moving differently than the background stars. So that's it. And as you can see right there is inferior conjunction. And actually, if we look at the sun now, we can actually look at the latest image. So this, let me make sure that I've updated this. I'm gonna see what time it says down here. Okay, so 0030. So this was taken a couple of hours ago. I'm just going to refresh this. Okay. Okay, so this is the latest one, and I think that is Mercury right there. So as you can see, okay, you know, you sort of draw an imaginary line here. It's getting really, really close. It's either that one or that one. I forget which. It's one of these guys, but really, really, really close, right? This is only an hour and a half before conjunction. But now, isn't this cool that we could sit here in the comfort of our own porch and look at Mercury? It's just, I think it's fabulous. And it's just fabulous. One thing I didn't point out, let's see if this is still loaded. Now, but here you can see these are the 4 stars that make up sort of the inner box of Cancer the crab. And there is the beehive right in the middle, almost in the middle. So this gives you a good sense of scale, and it gives you sort of a sense of how faint of an object we can actually see with this thing. So it's pretty good, you know. As I said, I think we can see down to maybe 4th or 5th magnitude. Hard to tell. I don't think I've ever actually figured that out, but it's yeah, these are pretty faint little stars here. So pretty good. Anyway, so yay, it's Mercury inferior conjunction time. Yay. All right, let me check the chat really quick. Yeah, I like this. As I said, I like this paper. Let's look at that next. So Tom posted this paper onto the Discord server, and I totally agree. This is just really, really fun, and you know, yeah, this is what it's all about: having fun, and you know, changing your perspective a little bit, seeing how things would be if things were just a little different, right? So apparently, there's this website that's called the Physics Stack Exchange, and somebody asked the question, supposing that the entire Earth was instantaneously replaced with an equal volume of closely packed but uncompressed blueberries, what would happen from the perspective of a person on the surface? so you know, you know, I mean, part of me is sort of like, man, is somebody actually gonna work this out? Does somebody really even care? You know, is somebody paying somebody else to do this? I don't think so. I think this is just like a student or somebody, you know, who saw this and it's like, oh, I'm just gonna do it. So this guy, Anders Sandberg, at the University of Oxford, worked it all out. And so I'm not going to go into the details here, but you know, he really dives in, right? He's looking at the density of the berries, and you know, comparing it to the density of the Earth and all that, and yeah, it's, you know, he works all of these things out that the blueberries are gonna turn into sort of a liquid as soon as the radius is you know, that many meters, you know, because of their, I guess because of their weight. I'm not exactly sure. So he puts an atmosphere in there because it's so big and the compression is so high. There's going to be heat created in the center, and so he goes through all of that, and you know, this stuff looks complicated. It really isn't. They're just integrating over a sphere. So you know, you have all these weird terms, you know, pi and r cubed and all that kind of stuff. He's just adding up stuff over a volume of a sphere. So yeah, no big deal. You know, he works all that out and it's a little equation, you know, that he can plug in a bunch of numbers and actually get a number out, right? So so this is the energy output of the sun over 20 minutes. Huh, pretty good. So the compression of the berry mass gives an energy of that many joules, which is the energy output of the sun over 20 minutes. Yeah, that's pretty good. That's definitely nothing to sneeze at.
Hey, Uncle Bill.
Hey, Uncle Bill, are you in the chat? Yeah. Hey, painting the chat yellow. We're looking at a blueberry Earth, Uncle Bill. So, yeah, blueberry Earth will become hot. So then, yeah, because it's so compressed, you'll have some kind of a solid core. You know, they call it an ice core. But really, what I wanted to get to was just sort of the summary, right? So if you're standing on the surface of the Earth when it turns into blueberries, the first effect is going to be a drastic reduction in gravity, right? I think he worked out that it would be about the gravity of the moon, so about like 1/6 that of Earth. Okay, so yeah, standing on the blueberries might be possible, but they're almost immediately going to compress, and air is going to start erupting, right? Because they're going to be compressing, squeezing all that air out that's around them initially. Basically, the worst earthquake ever.
So like Krypton.
Yeah. Except this is just a compression thing, right? So everything is going to fall 715 kilometers down. It's just going to go, right? It's just going to compress. So does not radically change the conclusions. The result is somewhat smaller and hotter. So there are still many things to explore. What's the likely chemistry of a blueberry world? Full of antioxidants, but there's a bunch of sugar in an extensive and hot atmosphere. Yeah, equation of state with a moist and deep atmosphere heat up further. I don't know. Could extremophile bacteria survive? One might wonder if this kind of exploration is worthwhile. I believe it is. I think so too. I have to agree with him that the fact of the matter is, right, is that the math is the math, right? The models are the models, and you can plug in anything here, right? You can plug in anything. It doesn't have to be blueberries. It can be something else. It can be golf balls. It can be marbles. It can be whatever you want, right? And you'll get a different result, which you'll have to try to interpret, right? Exactly what he has done. So yeah, I think it's fabulous. Hopefully he didn't spend too much time on this. I mean, if you spent like months and months and months, I would sort of be a little bit worried about him. But probably not. All this math is pretty easy, to find or derive. You just have to look it up and then plug in the numbers, as I said, and then I mean, a lot of the work is trying to interpret the results. It's like, what does it mean that there's that much energy produced, right? What does that mean? And he works that out. So very, very cool. I think it's great. I think it's absolutely fabulous. All right, so thank you, Tom, for that. That was great. That was really, really great. Definitely, you all take a look at that. It might when you actually go and look at other papers sort of working on the same kind of thing, the same kind of math, maybe it'll help you a little bit, lighten up a little bit and see that it all works. It just sort of depends on what numbers you put in. So hey there, I see somebody new in the chat. Yogi Peace, cheers.
Welcome.
Nice to see you in the chat. Welcome.
And he was asking, Uncle Bill Durham was something about asking, like, hot blueberry pie or too big to be a raspberry pie?
Too big to be a raspberry pie, I would say. too big.
And
Raspberry Pis are,
it's got a
you know,
nice at the altar.
yeah, exactly. Yeah, that's what I said is the math is the same sort of, regardless of what the numbers are, right? That's kind of the cool thing about um, being able to use variables, right? Is that you can plug in any number you want there, look at the results, see what they mean. So, yeah. So, Ayogi Peace, thanks for coming in. If you haven't subscribed yet, make sure to, if you like. This is just a fun, casual get together of friends every single day where we sit around in sort of a virtual circle or like a porch, and we just talk astronomy for an hour or so. Just, really, really laid back, really, really fun, but, you know, serious in a sense that this is science. So, I like to be extremely curious. I like to find out things. Um, extremely skeptical and extremely open-minded. So I like to have those three things in mind pretty much all the time. And fun, right? I mean, this whole thing is just fun. It's extremely informal. Um, just just having a little bit of fun, forgetting about everything else and focusing on the universe instead for just a little while. So I think what we
Free
should do tonight,
time, same back channel.
yeah, every single day, 2 hours UTC. So, iYogi, you're going to have to work out what that is, your local time, but I think you can do it. And if nothing else, subscribe, hit the notification bell, and you will be alerted. You'll be alerted. But this happens every single day at 0 hours UTC, so you can work it out from there. I know you can. So I think what I wanted to do today, we haven't in a while. We haven't done a constellation of the day in quite a while, so I think we should do that. I've got some not so hot coffee left here. So cheers to that in this nice thick mug, heavy mug. So yeah, this is probably, I've gone through a lot of mugs. I'm like Forrest Gump, right? I've worn lots of shoes. I've had lots of mugs, but this one I think is my favorite because it's so heavy and so thick. So cheers.
I used to have a mug that says, please don't smoke on the side, and on the bottom of the mug it says that I won't fart.
I've got one here that's that the kiddies drink out of. Here, let me. Kind of hard to read. So yeah, they let me know when that mug is empty, right? They let me know like practically right away. And I also have the hydrogen hydroxide again. This is a fantastic chemical. If you don't know about this yet, HOH, you gotta find out. It's great. It's great, and it's pretty readily available. So not too hard, to get just big gobs of it. So yeah, I've got a full mug of it here, HOH. So cheers. Always like to stay hydrated. Some hydrogen and oxygen. Great stuff. All right, so let's do a constellation of the day. And I can actually, because I'm now using my primary Linux machine, I can actually show you constellation list. How about that? Oh, Uncle Bill is coming onto the panel. Hey there, Uncle Bill.
Yellow, y'all.
Hey, painting the panel yellow. Wow. All right, I'm going to show you my constellation list, because up until now you've just had to, completely trust the fact that I have this list. So according to the International Astronomical Union, there are 88 constellations in the sky. And I have, as you can now see, I have a list. It's just a text file, right? But it's a list of all the constellations in the sky, north and south, in alphabetical order, right? In alphabetical order. So let us go over to, well, I didn't want to do that. I wanted to do that. Let's go over to, let's get rid of this. Actually, I'm going to get rid of that. And I'm going to get rid of that. And I'm going to get rid of Tom's blueberry paper. Don't need Twitter either. I'm just trying to minimize my... and I'm going to keep the Discord up just in case. So let's go over to random.org. And let the randomness of the universe choose for us today's constellation to sort of take a look at. Now, there are 88 constellations total, and I think if I remember right, there were 36 in the north and 52 in the south. So it's much more likely that a random draw like this is going to choose a southern constellation. So if you live in the north, like I do, this may not be incredibly relevant because you're not going to be able to see it, right? But everything else is, right? I mean, looking at the stars, looking at the variable stars, looking at the non-stellar objects, looking at the shape of the constellation, that's all relevant to astronomy. So it doesn't really matter if you can actually see it or not. All right, here we go. 1 to 88. Here we go. Bam! Number 35. Okay, so now I'm going to go to my list. All right, and I'm going to go to line number 35. So 35. This editor that I use here is called VI, and it's absolutely fantastic. But anyway, so let's go to line 35. 35, capital G. Equuleus. Equuleus is the constellation of the day. Now that is, I think that's a horse, and I think it's in the north as well. So let's go over.
That's called Daft Moon. Do you use it? I never heard Daft Moon.
Hold on, I'm not. Is there an F called Daft Moon?
If I can't spell it.
Okay. Daft Moon. Ayogi, I have never heard of Daft Moon. Tell me more. Tell me more. And as Andy says, punch the thumbs up if you so desire.
We mean it.
So
do it.
So it's Equuleus, Equuleus. It's It's one of those actual W words. All right, so let's. I don't know how to spell it either, Uncle Bill. I'm just going to do this. I'm going to cheat.
Great plan.
Here we go. Equuleus. Okay, here we go. Yeah, it is the horse. A little constellation, little one. Latin for little horse. Okay. So let's take a look at the constellation outline itself here. So yeah, pretty small. So along here is right ascension, and that's in hours, right? So we go from 0 to 24 hours all the way around east to west, and then declination goes all the way around from north to south, and that goes from a positive 90 degrees down to a negative 90 degrees. So this little constellation looks like it's right between Delphinus and Pegasus or Aquarius. Tiny little thing here. Wow, it's like half an hour wide and maybe 10 degrees high. So pretty small. Looks like just a few visible stars.
I've got my stellarium up on the Hangouts page.
Cool. I'm sort of wondering. Let's see. Can I?
Yeah.
Let me see if I can.
Clicked on his window and stuff on the Hangout window.
Yeah, I'm going to do exactly the same, but I need to. Let's see. I think I'm back here, so I'm gonna click on that. Is that gonna work? I think. Is every good? I'm waiting for my smartphone to. Yeah, you can see that. Yay! All right. Well, cool. So there it is, in the sky. Using stellarium. Is that right, Uncle Bill?
Yes, it is. That is my location at the current time.
Cool.
That's
So that means it's rising in your east, right? Because here's Altair, here's Deneb, here's Vega. So here's the summer triangle here. So rising in your east, and yeah, it's just below that.
Yep, just north of the equator, just west of Pegasus.
Very cool. Little tiny thing. Now how? Yeah, there's Mars too. So how do you figure that they saw a horse's head in that thing? I mean, what do you think they were on when they were looking at that? Because I mean, these people must have been on some kind of really interesting chemical, right? Or just or just extremely bored. I don't know what. Can you zoom in a little bit? Okay, so there we go. There's the horse's head.
Yeah.
Okay, well, whatever they say. All right. You can see Delphinus up here too, the dolphin.
Yeah, they had a lot of imagination, that's for sure.
Yeah, well, I think humans are like that. Humans are definitely like that.
She said that there's more stars and constellations in the southern hemisphere than the northern hemisphere, or she misunderstood.
I would say that there are more brighter stars in the south. Yes. If that's why there's more constellations, I'm not quite sure. You know, constellations, especially in the south, sort of came about when Europeans started traveling down there. Before then, there probably were constellations, but those have, you know, I think more or less been usurped by us Europeans. So yeah, there are
And
definitely more
here in the
stars,
north,
though.
we got some pretty big ones too that take up a lot of area.
Yeah.
Uh,
So I
Pegasus
think,
is a good example.
yeah. So I think it's sort of a combination of both. There are definitely more stars, which would sort of, you know, add to the idea that there should be more constellations. But also, Uncle Bill, you're right. You know, the constellations in the north, I think, tend to be a little bit bigger. So yeah, these even have some names associated with them and all that. Very cool. Very cool. All right, I'm going to go back to sharing my screen, if that's all right. Get back onto this. So this is more or less what we were just seeing. And usually how constellations go is that the brightest star in the constellation is named Alpha, right? And then the next brightest one is Beta, and then Delta, and then Gamma. And it sort of looks like to me that maybe that's not following the rule here exactly, but it's pretty close. It's pretty close. So, all right, well, let's see. Let's do a quick look at the Wikipedia entry, and then what I always like to do is I like to go to my Burnham's celestial handbooks and see what they have to say as well. So, yeah, you know, the brightest star is magnitude 3.9. So you've got to be in a pretty dark sky to, you know, even see that. You know, if you're in the middle of a city, you're not going to even see the brightest brightest star in this constellation. So pretty faint, pretty close though too. You know, 186 light years. That's in the neighborhood. There are some variable stars. Good. Some double stars.
In the way of deep sky either.
Yeah, it looks like there are some galaxies, and hey, that's all I need is a good galaxy. Only a galaxy, you know, with 500 billion stars. That's all. Nothing to get too excited about.
Oh, there's a couple.
Oh, are you finding some in Stellarium?
Yeah.
Okay, cool. Let's here I can.
Yeah, there's 4 down near the southern horizon, the southern border.
Okay, I got you. Yep. A couple of NGC objects, a couple of IC objects. Cool. All right. Well, while you're looking at that, I'm going to go run and grab my Burnhams. So hold on a second. I'm going to put you down.
Magnitude 14. Another magnitude 15.
Yeah, they're all really faint for sure. We'll see if HST has seen any of those two. So Burnham's celestial handbook is a 3-volume set that came out. I don't remember exactly when. I got my set in the early '80s, so I've had this set for a long, long, long time, and these books have definitely been through it a little bit. This one, volume 2, is missing the front cover, and I think the front page too. It still has that, right? So we still got that, and we still have the back. Still have the back to it. So this is pretty intact still. It's pretty good. Yeah, I've looked at these to death, as you can see. All right, so, and Burnham's is arranged by constellation in alphabetical order, so it's pretty easy to find them. And what Burnham's does is it lists, and there's not a lot here, it lists a bunch of binary stars that you can observe in there. You can sort of see a nice list of binary stars. Keep you busy for a little while. And then it also lists some variable stars, just a few. Now, according to Wikipedia, there are something like 25 variable stars. But when Burnham's was put out, look, there's only four. Only four. But it does show one of the binary stars in a little orbit there. So that's a pretty, those data points are pretty scattered around. They're trying to fit an ellipse to that, and, that's probably as good as you can get. But, yeah, those observations are a little funky. What's the scale here? Oh, well, of course. If you see the scale here on the side, right there, look at that scale. So that whole ellipse, right, is like half an arc second at its widest. So half an arc second is really, 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 really small. So yeah, I can understand why, at least at that time, there wasn't a lot of good data on that. So that's delta Equuleus. Equuleus? I guess that's how you do it. Yeah. Let's sort of see. Let's go over to Simbad and see if there's any more info about delta. Any sort of new info, right? I mean, as I said, this info in this book is like 30 years old. So it's good info, but it's dated. So let's go over to Simbad, and I'll just pull up the astronomical database, at least one of them. This is a good one, right? Because it's got everything. I'll hide that. And let's go delta Equuleus, delta Equuleus. Oh, okay, interesting. So they're calling it a spectroscopic binary.
And Ayogi Peace has something about Jack Moan and stuff.
It's all about astronomy. You can view the solar system, planets. Very, very cool. Yeah, Ayogi Peace, I think that there are a lot of apps out there for astronomy, and the ones that I've seen have all been really, really great. So yeah, if you've found one that you like and seems to work, I am all for it. So good. yeah, I've never heard of that one. So neat, neat.
Now, iYogi, is it available on Android? Because I got the Android tablet and Android phone.
We will see. Hopefully, iYogi will answer you. So here, let's take a look at this here. Quite sure why that's doing that.
Right now.
Cool. Okay, so it's saying that it's a spectroscopic binary. Lots of references. Guess I'm not seeing what I'm looking for. Yeah, I'd like to see if they have like a distance and an orbit and all that kind of stuff. We might not be able to find that out incredibly easily this way.
I was looking at the Google Play on my tablet. It says something about like Daft Moon phase, but I don't think that's not even it.
It says he thinks it's for Android.
Yeah, but I don't think I see it.
Okay. I have to poke around. Maybe around there somewhere. So let's see.
What was the question again, Bobby?
He was just interested in knowing if Daft Moon was for iPhone or for Android. It looks like it's for Android.
Yeah. There's an app called Daft Moon phase. I wonder if that was it.
Yeah, don't know. Don't know. All right, well, let's keep moving along here. I really don't see much of anything else in Burnham's. They are talking about a bunch of variable stars, most of which are faint. Okay. Well, let's. Why don't we go? Let's see. Eeny, meeny, miny, mo. How about? Let's see if any of these look interesting. Oh, they all look like galaxies to me. Let's take a look at this one. 7046. NGC 7046.
Nothing I can find out.
All right, so this, yeah, at least in the visible, this galaxy is really, really, really faint, right? A B magnitude of 14.2. But in JH and K, which are more towards the infrared, they're quite a bit brighter, right? 10th magnitude or so. And let's see, this is an SB galaxy, which they're not giving any kind of other designation. So yeah, that B just sort of means that that sort of corresponds to the density of the spiral arms, and B is sort of in the middle, right? So an S0 or an SA are going to have pretty tight arms, and SC is going to have pretty loose arms. So they're calling this an SB, which is sort of right in the middle. So yeah, not too tight, not too loose, right in between. Right in between. So let's see if HST has ever looked at this. Haven't I? The archive. No. So NGC 7046, NGC 7046. I'm going to do all images, all spectrographs, and everything else. It's fun. Look for it all. Ah, nope. HST has never looked at that object. Ah, too bad. But we can look at it here. We can look at it with the Sloan Digital Sky Survey. I think, is that going to come up that way if I do that? No, it's going to go back to that. So let's do this. There we go. And then we can zoom out a little bit and take a look around. So this is in the constellation of Equuleus. So let's see, 7046. We should probably... Uncle Bill, are you seeing 7046 on Stellarium?
All I've seen is ICs, actually. Let me look. 7046.
Let's see what IC number this is. As you can see, it's got a few names. It doesn't have an IC number.
46.
There's an RA in deck if that helps.
Well, Stellarium's locked in on something that is calling that.
Okay.
It's
well,
near those 4 ICs I saw.
Okay. Let me get your screen up. Stop sharing. And we'll get you on that.
Get a perspective. I switched to equatorial mode, so north is up.
Okay. Oh, okay, so that looks like that's probably it right there, huh? So zoom in a little bit. Yeah, right about there. And then I'm going to compare that to the actual picture over on Aladdin Light, and see if I can pick up those same stars. I think I am.
21 hours, 16 minutes.
Yeah. Okay, so you've got... Oh, yeah. So here's a triangle of stars here. And then there's this guy. And then there's this guy way over here. And if you look at the actual image...
okay, yeah, you're using this triangle. That works.
Yeah. So I'm going to share my screen again. We go over to the actual image. See, here's a triangle of stars. And here's this star, and then here's this one over here. And that's him right there. So yeah, that is it. That's it in the sky. So yeah, let me get you back over to Stellarium. Yeah, there he is. So he's almost not in this constellation, right? I think this is the border of the constellation.
Border.
Southern.
That's one of the 14 and 15 magnitude galaxies I found to start off with.
Yeah. I think Sinbad was saying it was about 14.2 as well. So, but that's of course in the visible, right? In the infrared, it's a lot brighter, which usually means there's just a lot of bright red stars. So cool, nice. Or a lot of what?
Or a lot of dust between here and there.
Yeah. Well, and that's probably also true, because we're pretty close. Does this give galactic coordinates here on your Stellarium? I'm not seeing it.
I didn't hear your question. I'm sorry.
Oh, galactic coordinates. Does it have that on the
Well,
stellarium there?
there's the Milky Way right there, so it's
Yeah. So it's pretty close to the Milky Way. So yeah, I wouldn't be surprised, that we're looking through at least a little bit of muck.
yeah.
For sure. Cool. Cool. All right. I think I'm going to share. I'm going to share my
Galactic
screen.
coordinates are available, but those work to a hotkey, and I don't remember the hotkey.
Gotcha. Well, I can look it up here easy enough, which I'm going to do. Let's see what the galactic coordinates are. So that's here. Okay, so actually 30 degrees below the galactic equator. So it's not incredibly close. But yeah, definitely in the vicinity still. So yeah, we should be looking through a little bit of muck there. It's a pretty, not very well studied galaxy. Let's see how far away it is. Oh, well, that's all over the place.
Screen topic. I can see it on the YouTube feed. It's still on Uncle Bill's screen.
Galactic grid. I don't have a hotkey assigned.
Thanks, Bobby.
I'll leave that for another day. I've got so many hotkeys now. I don't want to conflict with something else.
Hotkeys is gonna just burn the whole thing down. So careful with those hotkeys. All right, here we are. So yeah, you can see there's a little bit of a spread in distance measurements. So yeah, going from about 30 almost up to 60 million parsecs. So that's a pretty big spread. Let's just take the average of that, which would be 40, right? So a megaparsec is 3.26 million light years. And so then we're going to multiply that by 40, say. So that's 130 million light years away. So that's not really close. It's also not really far. So it's sort of in between. Pretty cool. Looks like there's pretty good agreement in terms of how it's moving, though. So radial velocity is about 4,100 kilometers per second, moving away from us. So yeah, that's a pretty good clip, I would say. Let's see if there's anything interesting in terms of papers here. Cosmic flows 3, galaxy groups, H1 regions. Are we seeing? Are we actually seeing? Yeah, I mean, it's close enough, right? It's close enough that we can actually see some pretty nice structure in there, right? Even with well. Yeah, with the Sloan Digital Sky survey, look at all these active regions, probably where stars are being formed. Now I'm seeing other galaxies here too. See, here's one, sort of a edge-on one. Maybe this is an elliptical. It's kind of hard to tell if that's a star or a galaxy. Here's a galaxy. But I would say that this galaxy and this galaxy is behind our main dude here. Probably, right? Because they're smaller, they're fainter. Assuming they're, approximately the same actual size, these have got to be behind it. For sure. Nice little group of stars here. Don't know if that's an accident or if they're associated with one another or not. Pretty nice. Nice color. Here's another galaxy over here. Oh, did I zoom out too far? Oh, we're still good. So again, here's that triangle of stars that we saw. So cool. Very cool. So yeah, lots of things going on there for sure. Nice picture. Okay, so let's go back to this stuff and just see if there's anything interesting. Anything interesting about this particular galaxy? It doesn't look like there's too much exciting going on there. Just a lot of cataloging and measurements. Yeah, nothing too exciting is popping up. All of these are really, really great, though, because they are launching points for discovery. One can learn so much just by almost randomly grabbing one of these papers and reading through. There's always lots of stuff in this, and then each one of these papers has a reference to lots of other papers. So it just goes on and on and on and on and on. And if you're curious and nerdy enough, and you could spend days just on this list. Pretty nice. Pretty nice. Okay. Anything else in Equuleus that seemed interesting? Really look like it. Doesn't really look like it. It looks like there are some variable stars. That's kind of nice. If you're into variable stars, for sure. All right, well, cool. So, little constellation of Equuleus tonight. A few stars, a few galaxies. I guess that's it. It didn't seem to. I didn't notice anything else on Stellarium in terms of non-stellar objects. So it looks like just a few galaxies, a few stars. Yeah. What else do you need? All right. Well, cool. I think unless anybody has anything else, I think I'm gonna get on out of here. Stop sharing my screen. Yeah. So anything else, anybody? Are we good?
Give me 10 more minutes with CalSky before we go.
CalSky? Sure.
Okay.
Sure. What do you want to do?
All right. Let me tweak on my screen share here a little bit.
Okay.
And that's going to be infinity and
we're falling. We're falling. Ah.
Okay. Let's zoom in a little bit. I talked about this some when we covered CalSky the other day. But if you go to under the calendars chapter, and then the submenu Meteo, this is where I get my weather from. And there's your typical satellite image. Okay. The ground underneath is like an average for a month or something. So you can't go by the snow cover or anything. It's just a cloud cover that you're looking at on that. I always skip over the satellite image anyway. This is the important part right here. Okay, and this shows, I've got so much cloudy weather, I don't have a lot to show you. There's a colored bar at the very top that gives you how dark the sky is. So when it gets black or deep, deep, deep navy blue, then I've got a good night as far as the sky being dark. And you see, I fly out of cloud cover too, and when I got the gaps in that, I see a little bit of blue. And let me see if I can zoom in on this a little bit more. There's also underneath that blue line a series of dots.
Yeah.
And when those dots get real tiny, like these here on Tuesday night, that means I've got good seeing. I don't have a whole lot of flicker and wobble in the stars.
Well, so they're packing a lot of information into a little bit of area. Pretty good. Pretty
Phases
nice.
and altitude of the moon. Okay. For each day. And there's a curve for that too, showing how the moon is rising and setting. All right. The red line, of course, is temperature. And this is a European site, so it's in Celsius.
Sure, that's fine.
Okay. Blue here on the bottom is my rainfall.
So is that a predicted rainfall? I mean, it's got to be, right?
Yeah, that's what I've got predicted for the next 10 days. Okay. You see my lightning storms. There are little indicators. Now, these I haven't quite learned how to read. These are my wind speed and direction.
Okay.
Little flags on each day to tell what direction and how much wind I have. And
Now, I
I'm
would
not getting much, but when I have a lot of wind, there's a whole bunch of little feathers on each one of those wings or veins, whatever you want to call them.
Yeah. I think you're reading that exactly right. I think the number of little feathers on the end indicates the wind speed, and
Right.
then where that thing is pointing indicates direction.
Right. And you'll see when I hover on there, I get a pop-up tooltip with a whole lot of fine print explaining how to read all this stuff.
Okay, I'm not seeing the pop-up.
Okay. No, it's not showing. Is it even showing my cursor?
At the moment, I'm not seeing your cursor either. Now I'm seeing it.
Okay. Okay. Apparently, when my pop-up comes up, you don't see it, and my cursor disappears too.
Gotcha.
But yeah, if you do this in your CalSky and you just stop your cursor on it, then you get a big black pop-up with a whole bunch of fine print explaining what all the different parts of the chart are.
Gotcha. Yeah, it's probably because you haven't told it to share that screen. You're just telling it to share this screen. So
Yeah,
that's probably why. Yeah.
If I shared my desktop, you'd see two screens full of stuff, and you'd be able to make out the fine details in any of this.
Yeah. No, this is awesome.
Yeah, and so this green line along the bottom, that's your wind speed also. You see kilometers per hour on this side.
Yep.
Okay. And I know there's got to be more packed in there too that I'm forgetting right offhand. But
What's this red dot along here at 0? I guess. Well, no, it's not going to be at 0 C, but see these red dots that go sort of horizontally across there. Yeah.
25. That must be 25 C. Usually it is on 0 in the winter.
Okay.
I guess it's just because it's so warm now that they made 25 C the default.
Oh, okay.
Looks like a flat line all the way across.
Yeah. And then I'm seeing, it looks like there's a date, right? Like 9, 10, 11, 12. But right under those numbers is like a 4, and then a 1, and then a 7.
I'm guessing that is the rainfall total for the day, perhaps in centimeters.
Oh, okay.
You're wrong. That's a wild guess. That's not something. Let's see. Red line is temperature. Green line is wind. Transparency on the top. Total cloud cover in the upper part. Bottom is expected precip in blue. Seeing is the dots across the top. And of course, the bigger dots mean the stars are wobbling around more. So that's
Yep.
four seeing. Let's see. The colors are whether it's nighttime or daytime. Uh, the altitude of the moon is scaled linearly from 0 to 90 degrees. Its phase is shown in transit based on GFS. It's not telling me what daily sum in blue letters. Expected precip is in blue with a daily sum in blue letters.
Okay.
But like LM squared, something meter squared. That don't make sense.
Yeah, I don't know.
L over M squared. I don't know what unit that is.
Yeah, we'll have to think about that for a little bit. Yeah, well, that is an info packed graphic. Holy moly!
Yeah, and there's probably somewhere I can get even more information on that. It's based on GFS, which is I think that's the numerical model they use.
Okay. Yeah.
And I'm not seeing a link to give me more information about how to read it.
Pretty amazing.
I might as well show this real quick too, just long enough to make it disappear. You can make that box disappear if you don't want it to.
Oh yeah, yeah.
Okay, and I can always open it back up again with that. But anyway, I just wanted to cover that real quickly because that was one of my favorite things I talked about repeatedly the other night and never showed it to you.
Nice, nice, nice. Yeah, Uncle Bill, feel free, to come in and show us different parts of this, pretty much whenever you want. There's so much to it, right? That
there is a lot, and there's a lot of it I've never used, so it'll be, I'll be learning it right along with you.
Nice, nice. Let's do that, from time to time. Pop in here and we can spend, 10 or 15 minutes or something looking at like one or two parts of this because, yeah, it's just there's so much here. Pretty awesome. Pretty awesome. All right. Well, I think let's get out of here for now. It's definitely oh wow, it's like 3:18 UTC. So yeah, I think it's about time to go. Let me check the chat here really quick. Make sure that there isn't anything too much going on. And yeah, CalSky, I'm really impressed. I'm not too happy that I missed it. So I try not to miss things like that. But that guy who's doing it, wow, that's a huge amount of work. So a lot of it now, I'm sure he doesn't have to, like run, but he has to develop all this stuff. He has to, fix bugs and all of that. So pretty amazing. Well, all right, let's get out of here for now. So thanks for coming in, everybody. This was really fun as usual. So yeah, if you haven't subscribed yet, make sure to hit the thumbs up if you so desire. Make sure to share this around too. We're trying to build sort of a core group, and there's a lot of you out there. I know there is. So come on in. As I said, this is just really fun, casual, but hopefully, pretty interesting. And I'm just sharing a passion. That's all I'm doing. I'm not really trying to teach anything or communicate anything. Just sharing a passion. I love astronomy. I always have, probably always will. So yeah, this is just really fun. So all right, I'm going to get out of here for now. Let's. Oh yeah, yeah, yep. They are calling. They are calling. So I'm going to get off of this planet. Off of this planet for now. It's just too heavy down here. It's too much, and it spins too fast too. It just makes me dizzy, and hats are. Yeah. I just can't stand it anymore. So I got to get off of here. All right. I will see you in a little less than 23 hours from now. All right. Take care, everybody.